What's going on, guys? Spud here from Survive at Southwest. Just doing an episode today on some basic map reading and navigation using a compass and a map. I will touch on GPS slightly, but today we're just focusing on map reading and navigation with a compass. Let's get into it. Alright, so today I'm using what's called a topographical map. There's a couple different types of maps out there. Topographical is mainly just shows the topography with some man-made features in it. The other sort of maps you can get are like your cadastral, which shows more property boundaries and bits and pieces like that. So I'm just going to quickly touch on some of the features that you'll find on a map. Okay, so starting with, obviously you've got land and you've got water. That's the basic. You got your major roads and you've got some property boundary on there as well. So looking at the map, so if we go over to this area here and you can see all these little fine lines in there, they're called your contour lines, and your contour lines show areas at a certain height above sea level, and they usually go in 5 meter intervals. So as you can see, you've got 10, you got 15, and all the way up to 45, 50. So that shows everything on that line will be a certain height above sea level, whether it's 10, 15, 20 meters above sea level. Now with the contour lines, obviously because they are going up in intervals of 5, the closer they are together, the steeper the ground's going to be. So that will come in handy a bit later on when I show you how to read the map to the ground. Okay, so some of the other important information here, especially if you're using a compass, is your north points. So that'll show you magnetic variation. Now that varies depending on which part of the world you're in. The part of the world I'm in is currently around 3. So the true north and grid north and magnetic north are 3 degrees out. So I need to adjust that into my calculations when shooting a bearing. Okay, also on a map you've got your legend, which tells you what is what on the map, so what it's showing you. Your scale, 1:25,000. You can get 1:50,000, 1:100,000. That just shows how much detail is going to be on a map. Each one of these grid lines or grid squares, so obviously you got your northings and eastings on here, which are these lines that run that way and that way. Each one of these squares that it makes, so that there's a grid square, is 1 kilometer by 1 kilometer. So they're all 1 kilometer squares. No matter what sort of map you're looking at, they will be 1 kilometer squares. Now when you go into a different size map, so say if you're going into a 1 to 50,000, they will be a bit bigger. As you can see, the map I'm using here, the grid squares are quite a bit larger, purely just because this map, I just want mainly the detail of where I'm going to be today. I don't need any of this. This map's just purely to show you what else you can find. Okay, another thing that's important is your adjoining maps. So that's the map we're using, and it shows which other maps will join onto it in case you are traveling in a way that you will leave a map. You know which map you're going to go on to. Alright, so we're going to head out into the bush now and shoot some bearings and use a compass. Alright, so I'm just heading up to a lookout point, which is an old survey marker, and just because it's the best place to be able to easily show relating map to ground, ground to map. So while I'm doing that, I'll just briefly touch on why I personally prefer using a compass and map over using a GPS. for starters, unless you spend a lot of money on a GPS, you won't get the topographical maps on it. You will only get your basic where you are and your waypoint. And if you can only see where you are and your waypoint, you can't know what sort of ground you're walking over, what you're walking into, whether you're going to cross a river, bits and pieces like that. And those bits are important to know that you're going in the right direction. Because if you can read a map and you know halfway between point A and point B you're about to cross a river, or you're going to go over a spur, bits and pieces like that, you know you're heading in the right direction. As good as GPSs are, they should only be a tool to let you know what you should already know, and that is exactly where you are within a few meter radius. But using them as a navigation tool, it's okay. I prefer using a map and a compass because I know a lot more of what's going on the ground. So I'm puffing a bit because I'm going up quite a steep hill. So I know more about the ground and where I am on the ground than I will with a GPS that way. Another thing with the GPS, depending on the time of day, how many satellites it can pick up, whether you're in tree cover or heavy tree cover or heavy cloud cover, all that can affect how well your GPS works and how responsive it is to you moving. I've been on searches where they've used GPSs as the main navigational tool, and we would have walked easily 100 meters past our waypoint before the GPS corrected itself and told us that we were already past the point. So that way, yeah, because you can do that you can make those mistakes with a compass and map, but at least looking at a map, I would know what else was around that waypoint to start with. And a GPS, unless you buy a top of the range one with topographical maps loaded into it, you're just not going to get the same as with a map. All right, well, I'm getting there. I've still got a fair ways to go, so I'll see you at the top. Another way is if I look over there and I look over there, I can see the hills there and there, and another one off to my side there. So using those hills and some of the tracks that are here, I know that there's a track that runs through this valley between this hill and that hill, and there's that track over there that you can see, and a track that runs all the way along the beach there. I can use those features to figure out where I am on this map too. So if we go back to the map and we have a look, so we have a hill here. All right, that's a low point. So they're 10 meters above sea level. Okay, we have another high point over here, and we have another high point 40 meters above sea level right here. So as you can see, it's in there. It's a bit covered by the words, but we have a high point, a high point, a high point, and a long high point over there. So there's a bit of a saddle in here, so there's a bit of a dip between the two high points. There's a big giveaway as well. Right, so if we look, that high point there and here, and high point there, so if we look around, just there is that hill, that's 40 meters above sea level. Just over here is a hill, and it extends around and joins on this hill. So using those two features, I can say that, again, I'm in that same area. So, once again, there's that hill, the hill I'm standing on, that other high point with that high point that runs around over to where I am. So once again, that has just confirmed where I am. So that's just using a map to figure out where I am. From there I can get a grid reference from the map, and I can let someone know where I'm in a grid reference. Going from, obviously, 1 square kilometre, I can bring that down by breaking that up into tenths, and I can make it a 6-figure grid reference. And then from there I can break it down lower. So you go from 1 square kilometre to 100 square metres to 10 square metres. And then once you go in any higher than that, you're in GPS territory, going up to 14-figure grid references, which will put you within 1 square metre. Usually for a rescue situation like that, a 10 square metre is good enough. So a 6-figure grid reference to 8-figure grid reference is usually good enough, and that's easy enough to be able to calculate in your head. Moving on to the compass, purely because the compass can help you get that grid reference. So this is a 1 to 25,000 map, and I happen to have, well, sorry, this one's a photocopy, so it's a little bit out. So you have these, okay, so you got 10 to 10, 10 to 10, 10 to 10, and you can see 1 to 50,000, 1 to 25,000, and 1 to 63,360. So they're your different size maps. And what you do basically for that is say, if I'm, let's just do it out in the ocean just so I can see, or you guys can see as well. I've got a point there. Alright, so this, yeah, so this is a 1 to 25,000 map. So 1 grid square, see that on 10, that one's on 10, so I can slide that around. And I can get the breakdown of that. So I've got obviously the grid, and then it breaks down further. So shooting bearings from a map with a compass. All right, so if I look over there and I can see that track and I want to head towards that track, I need to shoot a bearing. So I already know that I am right here, and I want to go just over here. So that's where that track is. Alright, so what I want to do with my compass in the direction of travel is I want to, using a pencil, not a pen, so I can erase it later if I get it wrong, draw a line. And always overshoot because it makes it easier. Then what I want to do is I want to line my compass up with that, and then swivel this housing around so north meets north. Alright, so let me just pick that up so you can see it. So that grid north is matching up with the north on my compass, not the swivel, with these lines in here, your lubber lines. So north is meeting north. Alright, so that gives me a grid reference, or a grid bearing of around 255, 256, roughly around that. Now if I was to use that grid bearing straight off the compass, I would end up being out over time, because remember at the start when I was talking about magnetic variations. So let's just use the back of this map. So you've got 3, so So let's just say that's the Earth. All right. That's the Earth. Now you've got three norths. You got true north, which is straight up and down. You got grid north, which is, oh, sorry, you got your poles, north and south. And you've got grid north, which is somewhere in between. And you've got magnetic north. So you've got three norths. 1, 2, and 3. Now your magnetic variation will vary depending on where you are on the planet. Where I am, it's about 3 degrees. It does change over time because the world does wobble on its axis. So this North Pole tends to go backwards and forwards, backwards and forwards. So it does change a bit. Now, in order to change that grid bearing I just took into a magnetic bearing that I can just shoot on a compass and walk along with, I need to plus that magnetic variation. So 255, 256 then becomes 258, 259. Right, so now I can check that because I can see where I want to go. So using the compass set up, I then want to set that to where it goes. I then move my compass around, so north goes into north. Oh, I've gone too far there. North goes into north in here. Up. And then I can look down that compass and look to where I'm going. Stand up so you guys can see it more. And I'm pointing directly at it. So now if I want to do the opposite and I want to just shoot a bearing, so we'll just reset that. Okay. Let's just stand this up a bit, eh? So I have where I want to go. Pointing my compass in the direction of travel. So you can see there's a little arrow there. That is my direction of travel. Same as that little glow in the dark piece. Pointing that directly at it, which it is now. I then want to spin the housing. So the north part of your needle is in the red arrow in your lubber lines inside your housing here. And once those line up, that there gives you your magnetic bearing. Alright, so this is good if I shoot a magnetic bearing like this. This is good if I just want to follow that. I don't need to do anything to follow that. If I want to let someone know which bearing I'm heading onto and they're using a map, I would then need to subtract those 3 degrees to bring it back to the grid bearing. Alright, so that's just a very quick way of using a compass and a map to find out where you are and to pick a direction or find it which direction that you're heading in. So what we'll do is I'll get off this hill, we'll get into the lower parts of it here, and I'll show you how to shoot a bearing and use the leapfrog method to make sure you're going in the same line. Right up here it's very easy because I can see where I want to go. If I'm down in that valley or not on top of a hill, it's very hard to see too far ahead because in some places here it does get quite thick. So you will need to shoot a short bearing, move to that bearing, shoot it again and keep going that way. So we'll get off this hill and we'll get into it. Alrighty guys, so as I'm heading down this hill, I'm walking along a saddle. So that's where I was up there. I'm heading over this way to where that track went. I'm on a saddle between two hills, so there's a depression down there and a depression down there. You can't really tell on the GoPro because of the fisheye lens, but it does go down on both sides. So I'm walking on a high point between two hills. Now I just wanted to say that this video is just very basic knowledge on map reading and navigation. I'm not going to go right into it. I have been a map and nav instructor for quite a few years now, and normally if you're on a course that I'm instructing on through the emergency services here, it's a minimum of 1 weekend. It's a full weekend course to do, and so that's 2 days in a classroom learning all these bits and pieces, and quite a bit of time out in the bush or navigating around. It is one of those skills that you do need to upkeep, so you need to get out and keep practicing to remain proficient in them, because they can be forgotten a bit. So yeah, this is just your very basic knowledge on how to use a compass and a map. I'm not going into full detail, otherwise this video will be hours long. So I'm nearly at where I'm going now, and once I get in there, I'll see you there. Alright, to prove my point before when I said it was easier to do when I was up on top of a hill, I'm now right at the bottom, and although I'm still on the track, my visibility off the track is down to about 10-15 meters, because I got hills on all sides. So I don't have the luxury of being up on top of a hill to be able to see everything that's happening around. So if I was to navigate out of here, if there was no track that I'm on, this is where I'd have to use a map to figure out where I am. Figure out a hill there, hill there. I've just come over a hill over the top of that to figure out where I am and shoot a bearing off the map and find my way out that way. So the way you navigate using a map and a compass has a lot to do with where you currently are. If you're in a situation where you can see everything around you, it makes it a lot easier. Where I am is quite hilly, so I'll be up on a hill in a minute, but then I'll be back down in a valley or in a depression, and won't be able to see anything again. So that's where using the map with the compass is great. I mean, I can do it purely through experience with just a map in the area that I'm in, because it is quite easy to spot where you are with the hills and the tracks and everything like that. But yeah, so this just proves my point that I was trying to come across before, where when I'm in the valley, I can't see outside of the valley, so I can't find those natural points to be able to figure out which way to go. So that's where I would bust out the map. All right, so I am officially out of track. I come off the track a bit before. Now my car is all the way on the other side of those hills. Now there is a valley right there, not that you can see it, but just after that hill there, there's a big valley under there too. Now I can see that from up here, but when I'm down in there, there is no way that I can see up past through those trees, because they do get a bit thick in there. So what I'm going to do now is I'm going to put you in first person mode up on my head, and we're going to navigate from here over to there. Alrighty, so just from that little time warp through there, that hill up there is where I was, and I went down through that valley, and you saw at one point it got quite thick. So each time I pointed, what I was doing is I was looking along my bearing, seeing as far as I could see something that stands out, and then walking to that, and then shooting a new bearing from that to the next point, and from that to the next point. So then that way I don't have to walk in a dead straight line. I can find the easiest way around, as long as I make it to that point that I've shot through my bearing. So say if my bearing pointed to that tree over there, I can just put my compass down, I can walk to that tree, pick my compass back up, shoot another bearing to the next tree or the next landmark that I can see. There's not much point in me shooting a bearing for something way up on top of the hill over there, because when I'm down in the thick stuff, I can't see it. So the distance of your bearings depends on how far you can see in there. So I've made it up to the top of this hill. That hill just over there, that's where I did the first things. That's the tallest hill here. So I'm on that one that's on 40 meters above sea level that I used to find my position before. And I know that just down here is the path that leads me back to my car. Alright, so I'm gonna leave you here. Don't forget to like, subscribe, comment, share my videos. Love the page. Check me out on Facebook, Survive at Southwest. There's lots of little handy tips and tricks on there. And I'll see you next time.